we know that W matrices are unitary matrices. So unitary matrix has the property that its determinant is equal to 1. So we can calculate the determinant omega. Determinant omega means AD minus BC. This is equal to the determinant W minus rho times W rho. Okay. And according to linear algebra, determinant can be factorized. 两个矩阵相乘，行列式啊，两个如果都是方正的话，可以写成个别行列式相乘啊。那现在个别的行列式会等于什么呢？啊？ Now, if I calculate W rho, this is the determinant of R minus rho W0 times R rho. Okay, and this is equal to determinant R minus rho times determinant W0 times determinant R rho。OK， 好。事实上，每一项都很容易算出来，但是我现在再多用一个特性，就是这个跟这个相乘啊。We can write this R minus rho times R rho times determinant W0. And the product of this is identity matrix. OK， 那单位矩阵的行列式就是1嘛。那 W0 的行列式会等于什么呢？就是两个对角分量相乘。So determinant W rho is equal to 1, and the determinant W minus rho is also equal to 1. So finally, we find the determinant of omega is equal to 1. I will use this very important property of this omega matrix. You can check this result in a complex and a tedious way, which means that you can directly multiply A and D and subject B minus B times C. If your calculation is correct, you will still get this result. 1. Okay. So why I need to know the determinant of omega? This is because usually if we want to find the f power of a matrix, we can choose to diagonalize this matrix first and calculate the result. Okay. For example, suppose we can find the eigenvector of omega b equal to lambda b. Okay. If I want to find the eigenvalue of omega, okay, then this implies omega minus lambda times I times b equal to 0. Then we know that this matrix cannot have inverse, because if it has inverse, I can multiply the inverse matrix to get b equal to 0. But we want to solve for eigenvector. Eigenvector cannot be 0. So this implies that this matrix cannot have inverse matrix. And once we have non-zero determinant of a matrix, we automatically have the inverse, automatically know how to write down the inverse of the matrix. So if a matrix has no inverse, it implies the determinant of the matrix is equal to 0. So this means that omega minus lambda I, the determinant of it is equal to 0. So this means that A minus lambda B C D minus lambda is equal to 0. Okay, so I can use this relation. Once I expand it, I find lambda squared minus A plus D lambda plus AD minus BC is equal to 0. And this is nothing but the determinant of the original omega matrix. Okay, this is just the determinant of omega. Okay, so we know that once we know the determinant of omega is equal to 1, this can be simplified as this. Okay, and according to this equation, we know that W is which means it is equal to 1/2 A plus D plus minus this is the two possible eigenvalues. Two possible eigenvalues of the omega matrix. Once you know the eigenvalue, you can substitute the eigenvalue into this matrix to find the eigenvectors. Then once you know the eigenvectors, once you know the eigenvectors, okay. So for the first eigenvector, the corresponding eigenvalue is lambda 1. For the second eigenvector, the corresponding eigenvalue is lambda 2. Then we can define S matrix as V1, V2, which means V11, V12, V21, V22. Here, Vij means the jth component of the eigenvector. 好，你看这边跟普通的这个矩阵的编号是反过来的啊，2、1、1、2，然后这边应该如果矩阵编号是1、2，这是2、1啊，也就是说这个东西是等于这个啊。